Okay, guys, today we learn about the trigonometry. Start from the basic. So, trigonometry itself is taken from three words, three, three, one, triangle. And we are measuring the triangle. And it is actually measuring not only the sides, but also the angle. Okay, triangle measuring. We have three basic trigonometric ratio. So we are talking about the ratio of sides, which is the opposite and adjacent and hypotenuse. So keep in mind, the first basic triangle is 90-degree triangle. Okay, and then let's assume the angle. So there is one specific angle which is 90 degree, right? So let's consider the sides. The longest angle, the longest side is called a hypotenuse in a right angle triangle, hypotenuse, or you can say H. And we have another two sides which are adjacent and adjacent and opposite, depends on the angle. So let's assume I use this angle as a theta angle. So this is a symbol of theta, and it is usually used in angle. So the theta here, Greek letter. And if I have this as a theta, the side that is opposing the theta called opposite, as simple as that. Opposite O. And the side that is next to it called adjacent. Adjacent or A. Now we are comparing two sides for each of the pair. So trigonometry knows sum of the ratio. Let's say I have opposite and hypotenuse, and then opposite and adjacent, and hypotenuse and adjacent, right? So we are comparing this, and in order to the agreement, according to the agreement of mathematician, we call the comparison of opposite and hypotenuse is sine. So let's say sine theta equals opposite over hypotenuse. O and A, opposite and adjacent, called tan theta. I will put it in the bottom, opposite over adjacent. And the last but not least, cos. So I usually memorize sine, cos, and tan, not sine, tan, and cos, just in order, just a matter of order. Adjacent over hypotenuse, adjacent over hypotenuse, not hypotenuse over adjacent. This can be reversible, right? So these three ideas, these three comparisons, is mainly used in understanding the right angle triangle. Focus on right angle triangle. But furthermore, we can use in a non-right angle triangle, which is called a scalene triangle. So we can use the trigonometry on a scalene triangle as well. So since this is overview, I don't want to go to the detail. So the memorization is soh, kah, toa. Just read like that. Okay, soh, kah, toa. So how do you find sine opposite over adjacent? Opposite over hypotenuse. And how do you find the cos adjacent over hypotenuse? And this theta might be various. Always a certain angle, and some of the angle can be memorized. So you can memorize the sign of a certain angle called a special angle. Okay, so theta is angle. Angle has two units. First unit, what we usually do is degree, right? The unit of angle. And the second, we call radian. So this is another form of the unit of angle, not only degree, but also radian. But later on, we continue that. I want to cross-check with the previous note. Hopefully it's complete. See? So we did this part, and we go for the special angle after this. Okay, so Every theta has a specific ratio of two sides of HOA, and we have three agreements, which are sine, cosine, and tangent. Can be simply put sine, cos, tan. Okay, the theta is always opposite hypotenuse, opposite adjacent, and the memorization is SOHCAHTOA. So you can rearrange SOHCAHTOA. Okay, and the theta. Now we go for the special angle. So I will delete this. Put this. Wait, not YouTube link. Here. Okay, memorize. Just memorize. And then we go to the special angle in a moment. SOHCAHTOA. And the angle is in might be degree or radian, but we are focusing later. We go to the special angle. But I think we need to understand about the degree and radian first. Okay, so in a whole circle, let's say I have a circle with this center, okay, and then the circle is in a random shape, random size, I mean the random radius, and we have this as an R and another radius, right? So let's say this is theta. We have the angle also. Now, the total circular angle, how many degree? 360. So 360 degree is equal to 2 pi radian. Okay. So 360 is a whole circle. A whole circle is circumference. Circumference of circle is pi d or 2 pi r. But since we don't have the specific radius, we don't have a number of the radius, you change the radius by radian. Okay, rad means radian. So we are talking about the conversion of degree to radian. So we try to convert degree to and from radian. Okay, now if we want to simplify this, not near equal. So from degree to radian, 360 degree is equal to 2 pi radian, right? So if you want to simplify, you do the algebraic working, you divide by 2, for example. So what do you get? Both sides divide by 2. What do you get? 180 equals 1 pi radian, right? Pi radian. You use RAD for the simple unit. So pi radian. So actually, radian is not degree anymore. You just change it to pi radian. Then, how do you convert, let's say, 60 degree to radian? So 60 degree equals to, remember the rule. I always teach in the same way. Put 1 first, right? It's rational, right? So 180 to 1, you divide by 180, right? And then you multiply by 60. So pi over 180 times 60 degree. Then you can cross out pi over 3. So pi over 3 radian. So this is the simple ratio that you need to understand. You can memorize, yes, you can, but I prefer you to use the ratio. Because if you don't use the ratio, it will be quite complicated later. Okay, converting degree to radian. I will give you some example on conversion. Yeah. Let's see how it works. So you just memorize 180 degrees, 1 pi radian. That's all. And the other will be following the rational rule. Again, how about if I have 120 degree, guys. Again, go to 1. So divide by 180, pi over 180, right? And then you multiply by 120. Multiply by 120, cross out. And then both divided by 6, right? 12 and 18 can be divided by 6, 2 and 3. So we get 120 degree is equals to 2 over 3 pi radian. Okay. Or if you want to convert from radian to degree, you can do the other way around, and it's same. Let's check one more time. Everything is simple, but mostly it requires you a lot of what do you call detail. Yeah, keep the detail in your mind. For example, if I have pi over 4 radian, what is the angle? What do you do? As simple as divide by 4, right? Because 1, this is 1. If you don't have any sign, it's 1. Divide by 4. Divide by 4, 45 degree, right? Okay, I give you another harder question. How about 2 over 3 pi radian? Oh no, we did it previously. 4 over 5 pi radian. How many degree? As simple as you multiply by 4 over 5, right? Makes sense? Just multiply the fraction. You multiply by 4 over 5. 180 times 4 over 5. Either simplifying or using calculator. Let's check. 180 multiplied by 4 over 5. You get 144 degree, right? Somehow, from radian to degree easier than from degree to radian. But how do you memorize that? I think I also provide you the memorization rule. How do you memorize that? Or are there any shortcut? Yes, there are. From degree to radian, you always divide by 180 to get 1, right? Times pi. So times pi over 180. That's it. Or vice versa. If I want to go from radian to degree, you multiply by 180 over pi. That's it. I think that's all the thing that you need to do. Okay, from degree to radian, you multiply by pi over 180. From radian to degree, you multiply by 180 over pi. You don't have to convert the pi as 3.142 and so on. No need. Just let the radian be in terms of pi. Okay. I think no. Just use in terms of pi. For example, Jolene asked 180 times what? Pi over 4, yeah. According to the calculator, 180 you multiply by pi over 4. Just do this, right? We have 45 pi. Wait, what did you do here? Okay, for example, this. Do you have to convert to this? No need. Yeah. Just do it in terms of pi. Just for your info. No need to convert the pi as 3.14. Get it, David? Yeah, that's the way you do for conversion of the degree to radian. There is a shortcut if you want to do it instead. But if you want to do it in the rational order ratio, just put 1 on one side and put the other number to get the answer. Okay, that's the conversion of degree to radian. Now, let's go to the next part, which is special angle. But before that, I want you to do this, convert to the expected outcomes, expected unit, for example, degree or radian. Degree, radian. Okay, memorize the rule. If you want to take notes, I will go back to the formula here. So if you want to convert to the red colored one, or you can do the faster way. Oh, you can do the logical way. Use the ratio. You just memorize 180 degree is 1 pi radian, right? Just take notes here and do the conversion right now. Wait, I think it's too big. Degree, radian. Radian is always in terms of pi, yeah? Take notes. Keep in mind, radian is always in terms of pi. I will make a bit longer. Okay, so fill in the blanks, converting to the expected unit by using the rule of 180 degree equals to 1 pi radian, or from degree to radian, you multiply by 1/8 pi over 180, while the other way around, from radian to degree, you multiply by 180 over pi. Okay, do the conversion. Wait, if I'm not wrong, yeah. I sometimes switch between this and this. I rarely use this formula. Okay, you may pause the video. You can do it now. Okay, let us discuss. 0 degree, how many radian? 0, because 0 times pi over 180. 0 times anything is 0. So pi over 6 radian, how many degree? 30, because pi over 6, you multiply by 180 over pi, right? You cross the pi, you get 30. That's the way you do. Because from radian to degree, you multiply by 180 over pi. So 30. 45 degree, how many radian? 1 over 4 pi. Okay, you get it. Or pi over 4, make it simple. Yeah. Pi over 3 radian, how many degree? 60. Good. Very good. 90? 1 over 2 pi. That's it. Pi over 2. Now, why I take these angles? Because these angles are a special angle. So we are focused back to the trigonometry of special angle. Trigonometry, trigonometry of, what is that? Of special angle. I missed the R. Trigonometry of, okay, lazy, special angle. So we have at least 5 special angles, which is 0, 30, 45, 60, and 90, or 0, pi over 6, pi over 4, pi over 3, and pi over 2 radian. So we mentioned the sine, cos, and tan ratio. Okay. I give you the simple memorization. If you can do sine, you can do anything. This is what I usually teach. What we usually get is memorize 0, half root 2, right? Half root 3, 1. I will give you the basic of this before we start to memorize that. I have another simple memorization. Put this, okay? Put the fraction. So this is the simple way. Put 2 below. Now what is changing is the fraction, sorry, the roots, radical, the square root. Put square root, make it easy. And you order from 0 until 4, right? From 0 until 4. 0 over square root 2, 0 over 2, 0. Square root 1, 1. Square root 2, cannot, let it be. Square root 3, cannot, let it be. Square root 4, 2. Over 2, 1. That's how you memorize. Okay? So this, I get this from my former students. They give me gave me this, and his teacher teach this way. So this is way more easy to memorize rather than you memorize zero. How it sounds doesn't make sense, right? It sounds I have no clue about how they memorize that. But for the yellow part, it's the basic. Thanks to my former tutor student, and he gave me this, and we can do everything later. How about cos? Cos is the opposite of sine. You start the zero here, right? You just oppose the order, right? Oppose the order one. How about tan? Tan is also simply put sine over cos. So this value over this value. Okay. 0 divided by 1. 0. Half divided by root 3 over 2. 1 over root 3. Right? You just cross the 2, pick the top side. The denominator belongs to sine. The numerator belongs to cos. How about this? Oh, the division of the same number, 1. And then square root 3 divided by 1, square root 3, right? Because you just pick the numerator because the both denominator can be cancelled out. 1 divided by 0, undefined. So this is not infinite, undefined. Okay, but you use an A better or do the dash. Okay, now 1 over square root 3 can be simplified further. Why? Because we don't have such square root in the denominator. You rationalize it just one time, only one, only this. You get square root 3 over 3. So you memorize this better. Okay. That's it. So dash means no value because tan of 90 is non-exist. Okay, that's it. Yeah. So first, if you like what I said, if you memorize sine, you can memorize all. Sine, simplify, 0 half square root 2 over 2, square root 3 over 2, 1. Cos, oppose the order. See? Opposing the order. Here. And tan is actually the division between sine and cos. You take 0 over 1, 0. 1 over square root 3 here. Square root 2 over square root 2, 1, same number. Square root 3 over over 1, square root 3 itself. 1 over 0, undefined. Okay? So it's an easy understanding for you. So you can memorize it easily. So find the easiest way to memorize. Okay, that's all for the degree and radian. Trigonometry of special angle. So you may pause the video and also try to memorize this. Don't forget to put the Sohkahtoa thing. Sohkahtoa is very important for you because it is the basic. Okay, some questions is here. It's given. Make sure that your calculator this in degree mode. Check your calculator, guys. Everyone check your calculator. The top side has to be D, stands for degree. But if you want to convert into radian, you can do this as well. Shift mode 4. 4 stands for radian. So they shift mode 4. You have R. The top letter is changing to R. So you can do the radian. Okay. Back to degree, shift mode 3 for degree. So that's for the input units for the angle. Okay, input unit for the angle. For example, what is sine 30? Do you memorize just now? If in degree, sine 30 is half, right? Sine 30 is half. But in radian mode, if I change this mode, the calculator will read the angle as radian. Wait, sorry. Shift mode run. So if I want to do sine 30, I have to change the angle by pi over 6, right? Pi over 6. So if you put 30 and it is in radian mode, it will mess up. pi over 6. It has to be half also. But if I change 30, the calculator read the 30 as 30 radian, not 30 degree. The number will be so random. See? So this is not the number that we expect, because you have to look at this. You have to make sure this R is radian. So the unit inside the angle has to be radian. So what is sine, or wait, I give you this, check together. In radian mode, cos that values half. So what is the angle then? Cos that values half. The value of the cos is half. So what is the angle that you need to put? Pi over 3. Yeah. Not 60 because it's radian. So pi over 3. So you put the angle here. And in radian or degree, depend on the reading. Pi over 3. See, half, right? Don't put half, guys. This is totally wrong. This is so wrong. The value is half, but the angle is pi over 3. If you put 60, something wrong, it's a random. Why? Because they read 60, the calculator reads 60 as radian. See, random. I don't have the idea what is 0.95. 60 radian, right? So make sure that you use, or you teach the calculator, or you put the right input on your calculator degree back to its basic degree. If you want to do radian, you just switch the unit radian. If you want to change back to degree, shift mode 3. This is the old calculator. If you have the other new calculator, you can check later. Yeah. Any questions so far? So we all just recapping all the Sec 3, Sec 2 materials. Okay, now we finish the explanation, and later on the next video or on the next explanation, we're gonna go for the quadrant theorem. Quadrant theorem is the harder trigonometry. So that's all for this video. I'll see you later, guys.